More than 800 million people suffer from migraines and other primary headache conditions, including cluster headache. At their worst, these headaches completely disable a person. As medical researchers continue to discover new features of primary headaches, the underlying causes remain unknown. What has been shown, however, is that certain areas of the brain are typically implicated in the perception of a primary headache. One such area is the trigeminal nucleus caudalis, or the TNC, located in the brainstem, which receives projections from many surrounding areas, including the nucleus tractus solitarius, the locus coeruleus, the periaqueductal gray, and the raphe nuclei. The TNC, in turn, projects to other areas, including the thalamic nuclei, where TNC excitation can be perceived as a headache. Research from Thomas Jefferson University, conducted in a rodent model developed by Dr. Michael Oshinsky, has demonstrated that gross overexpression of the excitatory neurotransmitter glutamate in the TNC leads to a severe migraine-like state in animals. Dr. Oshinsky has further shown that suppression of excess neurotransmitters can protect against and/or resolve primary headaches. In line with Oshinsky's research, gamma-core therapy increases inhibitory neurotransmitter levels in the hyperexcitable TNC, which can suppress or prevent attacks. Gamma-core stimulates the regions of the brainstem where inhibitory neurotransmitters are produced, including the periaqueductal gray, the locus coeruleus, and the raphe nucleus, targeting the effects exactly where they are needed, and not throughout the rest of the body, or even the rest of the brain. The gamma-core therapy is delivered by a non-invasive neural stimulator, which accesses a primary branch of the vagus nerve in the neck. The vagus nerve enters the brain at the nucleus tractus solitarius, or NTS, and comprises a variety of different nerve fibers, including A, B, and C fibers. Each of these fiber types has a different threshold for stimulation, and the gamma-core therapy selectively stimulates only the A and B fibers. By stimulating only these fibers, the gamma-core activates the very same centers of the brain that contain the inhibitory neurotransmitters required to suppress the hyperexcitation. Inhibition of the excitatory neurotransmitters in the TNC suppresses pain and prevents primary headaches. What are the potential consequences of the gamma-core treatment alternative? The three things that matter most to patients and physicians alike: significantly faster responsiveness to the onset of pain, demonstrable reduction in headache frequency and severity, and dramatically lower risk of adverse side effects.